Kostya, over to you.
Yeah. Hey, so my name is Kostya. I'm software engineer at Google. I have more than probably 7 years of experience. I started my career in Ukraine, then moved to just random city for a job, for a fun job, then moved back to Kyiv. Then, because of war, I moved to Europe, traveled a bit over the world, and now I am at Google. So in long story short, kind of that's how it worked for me. And today I will tell you about API protocols. I'll try to share it a bit of a story as kind of what I've seen in my experience, because I feel that it's more or less the most important thing. It's kind of what you see, what just your, yeah, how much systems did you see. I will try to give you as much examples as I can. So yeah, let's start. Basically, what do we have with API? Probably everybody is familiar with REST API. It's de facto standard for all of the communications. And I just attached how it looks like. It's super simple. You just send request. You just have response in JSON. I believe benefits of it, first of all, it's standard, like super benefits. Everybody knows it. Everybody knows how to use it, and it's powerful enough. It was developed, I believe, for like more than 20 years. So it's good. And because it's like so mature, there is a lot of ecosystem around it. So using REST, you can add like kind of whatever you want. First of all, it's cacheable. Cache is good, kind of. You want your requests to be faster. You want to cache. Second of all, well, almost each problem is more or less solved, I would say. If for you, for example, memory is a constraint, you can try to apply some techniques to reduce amount of memory. So the format we use for request and response is usually JSON, and it's more or less whatever kind you can read. But what you can do, you can introduce some schemas. You can basically, I don't know, use algorithms that will just reduce memory, kind of zip it. Also, it has a lot of like say, stuff like open API. So the idea with the problem with REST API is that your server can grow super big. And at some point, it's not one endpoint. It can be like, I don't know, 50, 100, whatever. You need something else that will kind of show you what are your point. You need some documentation you can share with your colleagues. You can share with whoever wants to integrate with your system. And you have open API for this one. And that's just examples that are on top of my mind. I believe just great go-to solution. What's next? Then goes GraphQL. GraphQL is developed by Facebook. It was developed, I believe, like in 2012. So not that much. They open sourced it at some point of time. And basically the idea is to be flexible. If we go back to REST, kind of you see in request, you just send some payload, whatever is kind of required for server to process your request. And it's the response, it's always the same. It's always, I don't know, it's okay, more or less the same, it's defined. But with GraphQL, you're the one who can you're the one who can describe whatever you want to receive. I believe this example is not good enough to be honest, but let me just try to find. Maybe I can do it fast. Okay, whatever. I don't have it anymore. Maybe this. No. So, like in general, you will have a big query, and in query you will just describe whatever you need. Let's just do it this way. Let's keep it simple. Uh, so you have kind of query. Yeah, here's a good example. So that's how your requests can look like. You you ask for a hero, you use some queries, use some functions kind of. These functions these functions are the one you define in your backend, and you get data. And it can be as flexible as you can it to be. So if your schema is defined, you don't know, can have age, can have power, whatever. And it will work as long as your schema is defined. And it's up to client. It's up to the client to ask whatever it wants and just get in the response whatever it asked for. Also, as it's kind of fresh, it already has mature infrastructure around it. So it has Apollo GraphQL and a lot of views kind of to see your schema. I believe one of views is as a zine, if I am not mistaken. Can just elaborate on this one a lot more later, but there's a solution how you can use a schema. GraphQL and so on can grow as fast as REST API. So like the idea is more or less simple, but both of them can grow. Both of them need a place you can just view whatever kind of you just need to know what you want to integrate with, and yeah, just already provides it, probably just one line of code. And what's next? RPC. RPC, I would say, the most kind of difficult way at some point. It's not human friendly. It should not be human friendly. The idea that RPC was trying to solve was more about memory schema enforcement and kind of you just call it a bit differently. So here you see you have kind of method name, it's name of the function. It was yeah, and this function is kind of called on the server. It was not easy to find any example because usually RPC is used for server-to-server communication. Usually just whenever you kind of have strong constraints. On web, you just do GraphQL from frontend to backend, or just do REST and you're more or less happy. But it also appears that it's used a lot in Web3. I was working a bit and with it, and kind of for me it was at some point tough to deep dive because again, GraphQL is understandable. You just know what you need to do. REST, super understandable, super just you already know it's with RPCs, and there are a lot of types of RPCs, like the one from Google. Here I use JSON RPC. Just need to deep dive a bit into spec. You need to deep dive a bit, I would say, into examples. That's how it works for me. Deep dive into examples, try it, learn by practice, let's say. And what's next? Protobuf. So behind RPC, the problem it tried to solve was efficiency. And for efficiency, we wanted to define a schema. So it's easier to kind of create this data. So imagine with JSON, you go back here to JSON, each time you need to, okay, this tool JSON, each time you need to send a lot of words, English words, kind of results, data, assigned ID for display. It's a lot of memory, and you don't really want to send that much of memory each time. So we introduced protobuf, serialization format. There are a lot of different formats. I believe protobuf is the one from Google. Just you just kind of describe the schema, and then you try to maintain it. You must always have the same schema on the server and client. It's maybe a bit of a problem. You need to maintain some kind of schema registry, and then you need to work with kind of evolving the schema. This to let's say you need to delete a field, and to delete a field it can be easy if you do REST. But imagine you delete it, but no, you rename it. For example, field error. Nobody knows how to work with it. Nobody will see any error. The integration will just fail. GraphQL probably will not. GraphQL is not easy to delete and deprecate. GraphQL tries to enforce, but tries to enforce some schema. But this one should just not work. And if you kind of delete it or modify some schema in bad way, it can fail first if you just work with it correctly. Sorry, this one. So what's next? Imagine that you have a task. This task is simple. You need to retrieve user, you need to retrieve their products and their orders and the exact products they ordered. And here is the schema how it will look like with a simple REST API. So client will go to user service. User service will fetch orders, will fetch products. It can be in parallel. It can be not, but kind of well, that's how it works. But what if we try to introduce federation? So federation, it can simplify merging of different schemas from different places. So imagine that you have a server, gateway server that just knows where it can get users, where it can get orders, where it can get products. It knows everything, how these products are connected, what types are they use, what is kind of the final schema. And that's more or less what federation was solving. I was working with Fire and it was super easy to use federation, to be honest. Like you have just one endpoint. GraphQL, it's always about one endpoint, more or less always. Have just one endpoint, you can get everything from it. And it's kind of like magic. You just ask whatever you need and it's just done. So feels good. So yeah, think of it like magic. And here's an example from the official documentation. So we try to get user with some kind of ID. We try to get its orders, its products, basically the same thing we are trying to do here. But now we use GraphQL for it, and we added federation. Federation, it's again already made solution. Probably there is different implementation for this one, but it's super easy to use. So you add federation to the system, you add a bit of engineering overhead. For example, that how the request will look like. So you just kind of, this is Nest.js example. I believe with, yes, Node.js, as far as I remember, Java looks more or less like this. Again, because GraphQL is kind of fresh and mature. Almost each framework that you use for GraphQL will have those stuff already available. So yeah, as simple as it looks like, just need a bit of overhead, a bit of resolve by reference function, whatever it means. You don't really need to know how it works. It just works, and at the end you receive some kind of this gateway, and yeah, just works. So what's next? Let's go over key strengths, and here I will give more examples for each of protocols and just how I see it. So REST API. REST API is super standard. When I was studying in university, I believe we covered only this one. It, well, just works. It has the most infra around. As I was trying to tell, just probably whatever you need, you can just find it available, open source. But the opposite of this one is that you need to get some kind of work done. You need to find a place, you need to find how to integrate, and it's not always easy. This REST API is, let's say, old, and you will find a lot of frameworks. If you go with GraphQL, for example, you find just a few frameworks. All of them are more or less good. If you go REST API, especially in the world of Node.js, a lot of different frameworks. But I believe almost every company runs like half of its infrastructure on REST API. Again, opposite of, again, the complex with REST, you need, and if you compare REST and GraphQL, you need to add endpoint for each task, and that can be challenging. So imagine you need to get a user. You define an endpoint for the user. Then you need to get, I don't know, user, but the user with some kind of more fields. Imagine you need to get user with amount of his friends. And if we add complexity for amounts of his friends, let's say amount of his friends, it for some reason is stored in another microservice. So to get user, to get his friends, you need to call two microservices. Usually you would do two. REST API requests for this. That's how it was done from my experience. You just don't want to serve this like tough, expensive fields amount of friends each time you serve get users, especially if the endpoint is high load. So you just add kind of one more endpoint. Then product changes, you get again some more endpoints, amount of cars, for example. Again, new server, new fields, and complexity grows. Amount of endpoints grows. That's the problem for REST, I would say. Just at some point, it can be tough to maintain. At some point, there is no just difficult to find source of truth. If you have a lot of microservices, each of them will have documentation. You can just merge it, but it's huge documentation. You don't want to read huge. Also, it just does not require kind of any architectural pattern from you. So you just want to write as you want. It will work, but well, if each microservice has different architecture, maybe different idea, just bad to maintain. Yeah, another pros is that it's super easy to cache. It just because REST introduces kind of each new endpoint has each new data, so like you super easy to cache it on front end because you can kind of have key. The key of the cache is endpoint name, endpoint you just pass, and bodies like whatever the response sends. So if we compare with GraphQL, the example with the amount of friends, amount of cars I was explaining, you can simply use framework. It will be another annotation, and you will say, okay, if anybody is asking for amount of cars, just use annotation. Okay, and then it will be more flexible. So when you request this one, if there is no amount of cars request, you will not serve it. It's super easy to integrate with. If anybody sends you GraphQL schema or UI to see GraphQL schema, you can just click on the UI, you can work with it, and you more or less know how to integrate. There is a lot of playgrounds that are just working. Because again, with REST API, everything may be different. You go from one company to another, from one product to another, it can be different because there is no kind of everybody can choose their own tools. With GraphQL, should be just one tool. It guarantees type safety. Schema involved, and when there's a schema involved, you're just sure that you will get whatever you kind of requested. It may be a bit more difficult to deprecate fields, to work with fields, but the guarantee is kind of a good one. And again, it has powerful frameworks around it. They just work, just kind of personalize them. I worked with GraphQL for one company, and the idea was that we need to make requests super kind of generic. So we have some entity, let's say car, for example, and we have kind of models of cars, but car each time looks exactly the same. And then we have shops of the cars, and each shop will request super different fields. So one shop can request, for example, country of producing age of the car, and another shop would request how much miles did it go. And you need to get some standard API. And as far as like there was hundreds of such shops, it would be tough to get separate endpoints per one shop. So we did GraphQL. Maybe it was a mistake for some point of time. So as I feel it, it can be kind of mixed. Some should be over REST API, but for this particular problems with shops, it is just great. I mean, generic version looks great in code because usually if you do code for generic versions, codes will be kind of bad. You don't want to support something generic, but GraphQL gives you this ability. That was just great. Another example was server-to-server communication, usually just again, super easy at another company. And RPC. RPC is the most efficient one. So if you have constraint over time, you have constraints over memory, you can use RPC, you can use it with some serialization schema. If you don't use serialization schema, I don't think there's a lot of sense in it, but with serialization it's just better. So RPC is good for streaming. With streaming, you usually don't want to send those big JSON files. You can just use RPC at some point of time. It may guarantee type safety. RPC as a standard don't guarantee it, but if you use it with schemas, it will. And code generation. In world of Node.js, code generation is kind of not a problem. There's different languages. And with some languages that are not TypeScript, you can just say, okay, this object is this type. That's it, forget about it. But let's say working with Java, those serialization schemas super important. You just define the project, you define the object, and then you can auto-generate class from it and work with this class. So it's super easy, let's say. I would say for Java, when you're speaking server to server, can be good. Probably, I don't really remember any experience when somebody will call RPC from frontend, so I will not probably do it. Can just add a lot of complexity. And yeah, negatives. REST API will just grow if you don't maintain it in a good way, as I told. It'll be just a huge server. It will reduce development overhead. Each thing that is, let's say, done for GraphQL, you need to do it. Another problem is overfetching or underfetching. Usually you may need to combine a lot of requests from frontend. So you need a user, you need whatever his products and stuff like this. And each time you ask for something, you just span network, and it's usually difficult to get from frontend to client, because like this route is usually a long one. When you speak server to server, usually they are in the same, maybe in the same Kubernetes cluster, just super close to each other, and server to server just responds fast. So usually you want to have like one request or two requests just to serve the page. So GraphQL. Problem for GraphQL is I feel that it's you usually have less control. As I told, the framework is good and the framework is powerful. But with powerful frameworks, the issue is that when it comes from tiny problems, it's super tough to solve it. So it solves like 95% of the problem, but you will for sure get this 5% of small problems you will need to solve somehow. I remember we had a framework with Node.js called Nest.js, if I'm not mistaken. And we needed to validate if the ID is GUID. And there was validation already implemented. But it appears that from like standard validation, you're not able to validate whether the string is GUID or not. And we needed to rewrite whole validation just to make this tiny piece working. So like, as I see it, the more powerful framework can be, the more issues you might have at some point. My friends working with GraphQL say that there is usually a lot of race conditions. So federation can solve things. It can solve it in parallel, but you don't always want it to be in parallel. At some point, you want to be sequential. For example, if you update something, if you, I don't know, change user, and changing user can change his orders. For example, you just want to delete some pending orders if user changes his age because he's not eligible. But it may appear that federation will go to order service before it was updated, and you will have race condition. And working with big systems, my friend just tell that, okay, you just need to find kind of hacks. Usually you don't have those race conditions. Usually everything is just great, but it may happen. So you just need to be a bit careful. Requests are more complex. Usually in request, you need to have request description of what you want to get. So you need to send schema each time, and schema can involve a lot of types. I remember we had requests, just kind of hundreds of lines of code because you want this user, you want user with particular field, you define type of user, then you want orders, with particular fields. And this schema here, it's super simple, but it will definitely grow at some point of time. And you need to send the schema each time you do a request. So this part can be, let's say, tough. And server-side complexity. Well, just REST API just works. That's it. GraphQL, you need to make it work. So if you are doing like 5 endpoint server, there is no need for GraphQL. And well, the last one is RPC. RPC is usually the least human readable. When you attach the schema, just like sequence of bytes, you don't really understand what happens there because, well, it's compressed. It's gets less memory, but at the end of the day, you may need to see the request. If you're debugging something, you may need to want exactly request that was sent. And well, like imagine that you have not updated your schema on the server, but you have updated it on client, or maybe vice versa. And it may happen that the schema is just different, and kind of the request that comes from frontend may transform into something a bit different, just small difference on server. But this type of issues can be tough to solve. It may require additional knowledge. So to use it, you need to know some serialization format. You need to just take a look at the documentation. That's it. That's complexity for sure. And again, schema registry. Usually you need to have schema registry, and it may involve even deployment issues. So when you deploy your servers, you need each server to have updated schema. So just you need to think about more things. Yeah, I believe GraphQL it's easier at this point. Schema was just easier for us, if I'm not mistaken. Yeah, I believe that's it. So please feel free to ask questions.
All right. So thank you for the comprehensive overview. And it's a very great insight from REST to GraphQL advanced capabilities. So moving on to like the Q&A, please submit the questions via Slido, which will be sent in chat. And also include your name. So also please let me remind you one more time to complete the feedback form for in chat for your certificate. So I would like my acquaintance probably to share screen. Rion. Hello. Um, wait a minute. So I so the questions are already on screen. It's feel free to answer them in any order possible. Hello, am I audible?
Can
All
you
right.
can you elaborate on what is Google API?
Sorry.
What is Google API? Like for someone new to APIs, what is the simplest way to start integrating Google APIs into a personal project? What do you mean by Google API?
Google APIs probably is like something like, do you know like Gemini? They have like some kind of APIs, right? Like
Yeah, I got the
the
idea.
Gemini, yeah.
So like my go-to suggestion would be maybe I can just simply show it how I would do it.
And I think for gRPC, it's also developed by Google, right? Or maybe he's asking about like gRPC.
Well, if you
Um,
know exact question, I would just have more exact answer. Mm. Okay, speaking of Google API, let me just share my screen. Just, uh, do you see my screen?
Yeah.
I just go to Gemini API documentation, and here we have examples. I would usually start with example. So here is get a Gemini API key. Just follow the instruction, whatever it says. Then you can start with REST, for example. So this line you will need to replace with API key you get from this thing. I believe you need to kind of create it, name it, just work with it. And yeah, I would say let's go to solution. Start with example. Maybe it should be code. If you want to write code, I don't know if you know some language, they have great examples. Let's like Python, JavaScript, Go, Java. Start it with whatever you just know. Try to use it. And then if you need kind of a bit more details, should be documentation. Okay, so quick start. Quick start is always the best thing you should read. And then you try to find documentation. So well, just Google it. Mm. Have not done it yet, so like I'll just open random pages, try to find something. Okay, so we have library. We leave library. Let's go to library. And your libraries usually have some interfaces. Libraries should be good to go. So just read these examples, maybe samples. Samples is always great. It's always great to learn by example for me. And kind of here you need, for example, live client content. Just click on the sample, take a look if it's the one you was looking for, and just, yeah, that's how it works. Probably the simplest way to start examples. For someone, okay, infinity caps under strict regs is REST plus GraphQL plus RPC hybrid viable long term. How to balance caching, real-time data, and traceability? Well, it's a tough question. I would start with traceability. I remember with HTTP, there is open standard. I believe it works for everything. So there is, let me just, I believe open telemetry maybe. Mm. Yeah, so the idea with traceability, I believe you can, like everything you, maybe with RPC it can be tough. Just RPC may follow different structure, but usually don't really need to have all at once, but usually you have some kind of key in your header. It works like this. When frontend initiates requests, you get some unique ID from somewhere, just maybe get it from your system, and it's called trace ID. Let's say trace ID. And then when the request comes into your backend, just know trace ID, and you just send it over all of your or all of your sequence of calls. It gives you this kind of this trace probably that you were asking about, and that's it. I know we did it. So first of all, I know that there is just go to solutions and you can try to find a library for it if you don't want to, if you don't want to kind of do it by yourself. Maybe it's solution you have to pay for. I believe it's not, it may be not free. If you want to go and do it more or less by yourself, if you want to kind of self-host it, you want to be a bit of DevOps, then try OpenTelemetry. I remember we used this one at some projects. I'll just send it in the chat. So, okay, I hope it answers the questions.
All right, there's another question saying, have you heard about Wikidata and SparkQL? Have you explored it yet before? If yes, please elaborate.
Uh, Not really. I believe Wikidata can just, maybe I heard about this one. Yeah, so I may be mistaken because I don't really work with it. But the idea about Wikipedia that it's open source solutions, kind of free to use. But how they make money, they will send graphs of data for some companies. I bet it's not free if you do it around Wikipedia, but this kind of knowledge graph may be important to build kind of dependencies what people can like. So, for example, if there is an article about, I don't know, about some person, and the article usually has references. These references create a graph, and let's say this person was interested into arts. So we have art. Art is kind of keyword. Then we go to art, and art might have some kind of other persons who are interested in arts, and we get this a bit of graph, I believe, this piece of graph, and then we may assume that if person liked the first person who was into art, we can assume that the person likes another one. But that's what I heard how people use it. Don't really work with it.
All right, thank you for the answer. And there's another question from Tim saying that how do gRPC core components work if you know? Specifically, its use of protocol buffers and the HTTP2 protocol contributed being significantly faster than traditional API. I've heard that gRPC uses some kind of like binary format, right? If they're communicating through.
Yeah, so like first of all, at Google, if there is a problem with speed, there was a lot of, let's say, solutions that was just made over HTTP protocols. And I believe Google was the one who pioneered HTTP2 protocol, HTTP3. Because like usually it works like the big company needs to solve their issue, whatever it means. It can be security issue, it can be issue with speed, something, I don't know. And they will try to implement it. They will try to go like, so I see it's first of all you approach it with your tools. So let's say your communication is slow and you need to make it faster for some reasons. We just try to see, okay, let's say we are requesting user. We are requesting user with some of his fields like name and age. We can ask, is really age essential? Maybe we can reduce it. So we just remove unnecessary fields, create another endpoint for it. Then we can see, maybe we can optimize something on server. Maybe like age takes a lot of time to get from another service. Maybe we can cache it. So you would use some techniques that you just know as the simple solutions. At some point, you will use all of those tools and still you have a problem. So I'd say those techniques are more than enough for a lot of companies. Like if you go to work, I don't know, any company, more or less any company in your local markets, just enough. But if you imagine scale of Google, for example, Google search or Google Ads, they're super load services and we need to make it more faster. We need to count each byte that goes over network because each byte comes with money. Each byte comes with some resource used. We want to minimize all of them. I believe that's how gRPC was created. Just the idea is you maintain schema and you don't send a lot of human readable data. If you want it to be fast, just can define a schema. In the schema, you can be kind of generative as, as you want. For example, with enums. Enums is a great example. So imagine that a user can have a status. Is it young or not young? Okay, is it? Let's say let me think. Uh, okay, so user can have a car, and let's say he may have Honda car, he may have Toyota, or he may have Mercedes. Let's imagine it's three models of car, and you can send those models each time you send a request. But you can do enum. So you can define that Honda is number one, Toyota is number two, and Mercedes number three. That's how you just save the data. I believe that comes into protocol buffers. The protocol should not, well, you may send just less headers, you may send less, not necessary payload, but that's how it works. You start small, start with your tools. If they are not enough, just create something on your own. Yeah.
All right, there's another question, and it says, I have a question, and I'm sorry it's out of context. Can you give some tips to become a software engineer at Google based on your experience?
Yeah, sure, like happy to help. I would say uh, the best advice, it's kind of either you can be the one who Google will follow by its own. Like Google have a lot of budget, and if Google really wants to hire you, he will hire you. But maybe the most simple version would be to think kind of where actually Google hires. So imagine in your local country, there's 5 open jobs, and like everybody wants to go to Google. Like a lot of people want to go to Google for sure. So like it will be very competitive markets, but at the same time, if in another country it's like 100 jobs, well, competition will be a bit smaller. So you can kind of ask a question to yourself whether you really want to have the job in your country or you're open to relocation. And it really simplifies things. If you're in relocation, then just gives you kind of more availability, more jobs accessible, and then, well, that's how you get the interview. How you pass it, it's how you just complete the interview, it's another question. I would say do a lot of algorithm tasks. That's it.
All right, thank you for the answer. And there's also a question from Balan saying that we saw that GraphQL offers more flexibility at the cost of higher development complexity. At which point do you like? At which point you would start consider using GraphQL instead of like REST API or other API methods?
Uh, I would say when your REST API is just so big that you can't really maintain it, you might think of GraphQL. So I believe you just kind of a bit of feel it. Let's say like this, you can count it, you can definitely measure it. But what I would suggest is that imagine you have those users, and at some point your users endpoints just you have like 50 endpoints that return different things for user. It's super difficult to maintain, and it's kind of if you need to combine those endpoints somehow, you add 51st request, it just grows. At this point, you may think, okay, we don't want REST because it just adds so much complexity. It's difficult to maintain. We can try GraphQL because GraphQL will simplify. We'll have just one endpoint, and each client will ask whatever it wants. And maybe it can be architectural decision from the beginning of the system. And usually it's more difficult to rewrite code to change some architecture, then also understand that you will have a lot of clients from the beginning that will most likely ask for very different schema, very different responses. Then you just start with GraphQL to make things easy.
All right. Then there's another question from Sabrina saying that comes to API deployment, are there significant differences in the infrastructure and configurations required for RPC compared to those of REST and GraphQL?
I don't think it's differs a lot. Probably no, kinda. There should be different techniques how you just use it, how you configure it, how you, for example, verify that somebody who is calling you, it's the one you want to respond. So there's technique kinda to pass tokens, and I believe RPC can pass it differently, but it's more of kind of how you develop application, not how you deploy them. I don't think there's kind of strict requirement that you need to deploy RPC only this, kind of only with this architecture, only with this infra, and REST and GraphQL with another. I think the thing I want to highlight is you need to have schema registry, and this one kind of differs for REST, RPC, and GraphQL. You need to have the schema somewhere. Maybe for GraphQL, it's not like it's super nice to have. Usually you would have it. You can live probably having kind of different schemas in different places, and probably well schema is a bit in different places usually, but with RPC you just need some schema registry. If you do protobuffer, if you do serialization stuff.
All right, thanks for the answer. There's another question saying, just wondering, is GraphQL a good choice for mobile apps where the internet might be slow or unstable, or would gRPC be better there?
I heard that Facebook uses GraphQL for their mobile apps. If they do, it's stable for them. And I believe like Facebook is good enough. I don't think, well, internet is unstable. It just depends. Kind of if request is broken, if the internet is slow, that can be a thing. If the internet is slow, maybe like you can use some kind of gRPC because it just has less data in transition and really less data in response. But usually internet is not kind of thing that is slow, especially in Europe, let's say. Usually if it's slow, we just wait, and I don't think apps really, well, maybe some crucial stuff can be and should be faster, but well, usually it's kind of you just wait, and it's okay to wait. If it's unstable, probably your request will be just dead. You will need to send one more request. Like, I mean, probably you can work on it, but most likely gRPC, GraphQL, or REST does not really solve this problem. You will need to attack it in a bit different way.
All right, thank you for the answer. Next question. What are the potential security risks of GraphQL and how can they be mitigated? How can they be like,
Yeah, I understand.
yeah.
So you can expose too much of schema. Like imagine that your user has password and for some reason, or your user has token, and for some reason you want to expose this token. Like, okay, imagine you have a user that uses Gemini API key to generate some kind of response for him. And you ask the user to just give this API key to your system so you can, I don't know, store it and kind of use his API key for his requests. And you may accidentally expose this key, and it can be a vulnerability. Kind of just if you have, I believe it may be a bit, oh, it's you may kind of play with server communication. There are some types of requests that you don't want to be visible for client. If they are visible, well, that can be a problem. But again, kind of GraphQL does not introduce risks on its own. It should not introduce risks on its own as a framework. It's rather how you work with it. Maybe it's more easy. I would say it's more easy to do vulnerability with GraphQL than with REST, because with REST you just ping each time you send response. With GraphQL, you don't really know who is requesting this, and that may be a problem.
All right, there's a question saying, how does it feel to be able to work at a cool tech company like Google? And how does it feel to be a Googler? And can you please give us some advice?
Well, thank you for the question. I don't think I can just feels great. I mean, just depends on what you want, depends what's cool for you, but feels great. And let's say for me, the most important thing it's first of all people. People are super great, super talented, and yeah, it's just about surroundings. Because usually, what defines you as a person, it's more or less your surrounding. If you're surrounded by great people, there's more chance that you will be great, let's say. And another, it's the product itself, the company itself. Google do a lot of great things. Google do a lot of good things, like just open source a lot of stuff. They just do a lot of good. It's I'm proud to be like part of such company.
All right, thank you for the wonderful answer. I think we should cut the last question over here, which is what is the key difference between gRPC and RPC? And are there any specific difference between their underlying mechanism?
Probably gRPC is just more optimized at some point. Like how it works, RPC just more pro. If I'm not mistaken, I don't know exact differences, but how it works is just kind of RPC. It's more common standard. gRPC is the one from Google, so like Google made it for a reason. You don't do like anything without a reason, and most likely it's just faster at some points. So Google like solved some bottlenecks. Maybe it's more reliable at some point. So kind of you need to deep dive into this.
All right. What a fantastic session. Thank you, Kostya, for sharing your expertise on modern API protocols, from REST fundamentals to GraphQL advanced features. You've provided tremendous value for our audience. Thanks for everyone for your engaging questions and participation. Your curiosity made tonight's discussion truly special. And let me remind you one more time, please complete the feedback form in chat for your certificate. You need full attendance and a completed form to qualify. Thanks to our organizing team, Rion, Ita, Evelyn, Rama, and the whole GDGOC Indonesia for their support. And tonight's API explanation has been very enlightening. So whether working with REST, RPC, GraphQL, I hope you feel inspired to apply these technologies in your product. This concludes Talk Series 3. And please watch our upcoming events as we continue exploring cutting-edge technologies. Thank you for being part of our tech community. Lastly, I would like to invite all of you to turn on your camera and let's have some photo documentation first. I'll give the stage to Rion.
Okay, maybe from me for the documentation for the last for this event. Okay, guys, prepare your camera, turn on. Ditunggu sampai 10 detik deh. 10, 9, 8, 7, 8, 6, 5, 4, 3, 2, 1. Oke. Oke, siap-siap semuanya. 3, 2, 1. Smile. Okay. Maybe next we can do the GDGOC. Kayak gini ya, teman-teman.
GDGOC logo, like the
Yes,
Google
yes.
Developer Groups logo. Let's do it. 3.
Oke. 1, 2, 3. One more. 1, 2, 3. Okay, thank you everyone.
All right. Thank you for the session, Mr. Kostya, and have a wonderful evening, everyone.
Thank you for inviting me. It was a pleasure.